So Johannes, do you have a question on this? This is
let's start with a question in the chat. Michael.
Yeah, a question. You showed the diagram for static linking static library at link time. Is it also possible to have shared objects, so dynamic linking in some way?
Yeah, there's actually showing two things here. Linking with bitcode, and we're also showing linking the ISA with NVLink or LLD. What you're saying is a host shared object that would be applied the far right here to the application itself. There are no GPUs that I'm aware of that have this, and I can't say whether they are, but it's certainly possible that that somebody will come up with a method of doing a dynamic library for during execution. And there's actually some really good use cases for such a. So, but that concept of finding that and building those should be, in my opinion, should be similar to the way that you would do it for the host. So this is extendable to shared objects, but right now there's no, in fact, this dotted line here, we still don't have completely, we have early ability to do linking, but it's not completed yet where we can actually link external code to the actual final ISA. So we do have some ISA level linking capabilities, but not so much as not complete. There's still some ABI type of work that we have to complete. So that's different than I think what you're asking for. And there just aren't any GPUs that I'm aware of that actually provide the ability to have a library, a runtime library that that is dynamically loaded functions from a library. Does that answer?
It doesn't. Yeah, it doesn't necessarily need to be done like on the device, but I think of that you can load your one of the applications, collects all the shared objects. I don't know, it makes and prepares whatever is executed on the GPU. It's not necessarily I think required to have the dynamic linking to take place on the GPU itself.
Yeah. Yeah, in the case of OpenMP, where we put it into an image that we load, and we have to launch kernels from the runtime with a specific name. It's that kind of bookkeeping isn't there yet to do that dynamically.
Yeah, we don't have a loader in the runtime that would go and find the symbols, which is
and furthermore too, I know a lot about the HSA. You have to actually sort of freeze that object before you can load it, or before you can execute it, an executable. So there's some work to do in the architectures to make that capability. And I think in some ways that's nice, because it's forcing us to actually do more optimization. But in the end of things like printing and I/O and a lot of other things that don't need to be optimized, right? Or that are relatively take a lot of time compared to actually the computation. Those things are all great candidates for the kind of stuff that you want to do there. And that's, I think that as we get more use of libraries, we're going to start growing. And another topic that I wanted to present is this notion of host remote procedure call, where we actually would have a library that would allow more capabilities on the device, but it would really be a stub that executes the functionality on the host. And this is a good thing for something like an MPI library. So all of those things are candidates for a more robust device runtime that you're inferring there, you're leading on, but there's a lot of work to go before we get there, right? In fact, this piece here is like base work. Let's get it so that we can at least do static libraries, right?
Sounds good. I'll say, you want to ask a question?
Yeah, sure. Hi, Greg. So some of these changes will eventually need to go into the ELF format, right? Like if we're thinking of interoperability between compilers or something like that, what are those changes that will eventually need to go into ELF, if there are any?
Yeah, this is and again, this kind of goes back to, you know, the compiled objects here are you know, have typically the host object code, and the device bit code, or we call it stuff, right, as part. And today the convention is to put it as part of an ELF, and it's actually an ELF full of ELFs, okay, because it's one for, you know, there actually could be an ELF section, and within there you actually could have multiple devices, right? So and that turns out that there's enough capability in the ELF to do that today, right? So there really doesn't seem to be any, you know, ELF, any things that we cannot do with ELF. Jan might have some other opinion on that too, but the extraction tool works with knowledge that those sections are there and pulls them out. We just need to, you know, do the right handshaking between the bundler and the unbundle archive, and of course, having it in the same tool makes a lot of sense. I don't think there are really any issues with or any extensions or changes we need to do to ELF.
Yeah, I mean, you got to pay attention. You can't extend just ELF. Then you would have to do something for Windows and some other OSs, right? So you got to stay within the boundaries.
Yep. Thanks.
Are the bundles?
By the way, Ravi, thank you, Intel guys, for working with Jan. It's not just Jan worked with Intel. They had some ideas on this, and some of their ideas, we merged them together for this. So thanks for your help with that.
Oh, thank you for doing the work.
Are the files that the bundle system generates compatible with, for example, the GCC bundle files, the ones that are generated by MVPTX tools?
I'm not sure what GCC is doing, but one change that happened is, and I want to point that out, is that this .o file really is compatible with regular host objects. So as a result of just putting these .os into an archive, like down here in this red box, notice that it passes directly with nothing done to it right into the host linker. That's a really important thing. That's a great change that was made in the last year or so. So we don't have to do any processing on that. So I don't, you know, so the format of the .o is very host specific and host centric, including the symbol information, etc. So my guess is that will be compatible with GCC. However, what I don't know is compatible is if GCC has the intelligence to pull out that information from the ELF section that's in here. So they may need some similar tool like we have here, Unbundle Archive, to pull that out to create something that they could use in the device linker. So I apologize, I don't have a lot of understanding of how they're doing their GPU work on GCC.
Okay, thanks, Greg.
Okay. I have one high-level comment on this and this slide actually, and I think this all is very reasonable, and we need basically all of that functionality. But the one thing I still kind of believe, and that is something we haven't really worked on in direction yet, is that everything you have in green here, no, sorry, at least in the lower part, everything in green should actually be part of the linker. And if that would be the case, we wouldn't need to spread it over multiple tools. It would be way easier to determine, for example, if one was found and so on and so forth. So all of what is green here down there should be part of the linker. And that is something we haven't explored yet properly, but I still believe that that is the right way to go.
So, Jonas, why do you think it should be part of linker? It could be, these tools could be called by anything, even linker or driver, client driver, right? Why make it be part of linker?
Because like the one first thought is because you're linking stuff. Like literally what you do here is you link things. So why make it part of anything but the linker? Second thing is you need all the functionality that the linker has with regards to finding symbols in shared libraries, finding symbols in static libraries, determining what to include and what not to include. It's like all these things are already available in the linker. The linker can do the LLVM link, the linker can do the LLVM optimize, the linker can do the LLC, all of that is available, like the middle green boxes. The linker does quite natively, because it's a linker, does the linking part, which is the fourth green box in the fifth one. So basically you get four of the boxes for free and all the functionality you need for the downside, for the lower part, sorry.
Right, and you're absolutely right. And all of these boxes actually could be done right in memory. And they're, basically what we're doing is showing how you would do it in a series of tools. But the linkers are so advanced today, they have plugins that allow you to do that. And this would kind of represent at least the logic, not necessarily the tool chain, that a linker would do in a plugin. Like the Gold plugin today could take the bitcode and do the optimization on it. So I agree with you, and I'm basically showing you the logic then. Okay,
agreed. Yes.
Plugin would do. So somebody else on my team had the same comment, right? This is just too, this is just too complicated a set of tools. But my point is to try to show what you would put into a logic and do that's all in memory from a linker, and just, and again, draw a, extend that. I should have put that in a different color on the far left, and then just draw that box around everything and hide out all the guts on the inside, because it should be able to be done with a linker, including, these linkers should know what to do with a bundle that has an ELF section for device code. The only problem with that is that that the current, well, it's not a problem. I just want to make it clear here. This unbundle archive is kind of on demand, because it's called when the device linker is linking for a very specific GPU, right? You, the user, asked to do a build for a CPU and a GPU, or a collection of GPUs, right? So it's going to try to do the extraction, this box here, for a very specific, or it's actually going to look first through the file system to see, through the library structure, to see if there does exist something device specific, and assuming it doesn't find it, it's actually going to pull out of there, single input and a single output based on what is needed. So that's another thing to consider in trying to do this thing all in memory, is that what we're going to see is more and more fat libraries out here that have, and we don't want to bring every object from that library into memory, because we don't really need them all.
That's
the point. Need all of those different components.
During linking, you know what symbols you actually need, and you can extract only those ones.
The problem with doing everything in linker is fine, but you may not have the same support on all the OSs, right? So you don't want to modify anything in the native linker if you're going to use that.
But the LLVM plugin, for example, runs on all.
If it does, then fine. Yes, if it does.
There is a way to use it under all operating systems on all.
No, I think there is some where they don't support the plugin. I'm not sure.
All three major linkers support it. So there might be like obscure linkers that do not, but at some point it is questionable what upstream is going to kind of promise, right?
So we're going to take that. I mean, we have heard that comment before. We know that it can be done. It's just that this was kind of a first step to make it understandable, especially to introduce the terms, an offloading library here, what that really is. It's something that's fat, and it has both device code in it and it has host code. And then this notion of device specific, because many tools don't know, we want to be able to pull out exactly what we need. So anyhow, it's a good comment. I definitely agree. And if we get an intern to do that, we can, if somebody interested, call me. I'll tell you what we have to do, or call Jan.